Today we're going to continue on with lesson 4.5. We're moving on to solving trig equations. I really want the main focus to be on getting yourself ready for the test on Friday. Regardless of whether we have a full day or a delay, we will still take the test. If we have a delay, we'll just do one part and finish on Monday. I will try and keep the notes fairly short. I don't have a handout. You take notes as you see fit, trying to keep it on the lighter side just so, as I said, you can keep your focus on the test. We're going to go through a few examples on solving trig equations, and then there's an Excel assignment that will be due Friday by 7:45 a.m. So today, as I said, we're solving trig equations, and we really have done some of this in the first part of this unit as well. So let's take a look at a few basic examples. If we were looking for the cosine of x is equal to 1/2, and we are not using our graphing calculator, we're trying to think on that unit circle. So let's go draw a quick unit circle. When is my cosine equal to 1/2? So I'm looking for the smaller leg to be here and the longer leg to be here. So one option would be this triangle here on the unit circle. The second option would be this triangle here. Let's look at a couple of scenarios. They might tell you they want your answers for x to be somewhere between 0 and just plain old pi. If that was the case, the only answer I can put is this solution right here. Notice this angle is the larger angle, which means it's 60 degrees. However, they want that in terms of pi. That 60 degrees is equivalent to pi over 3. And we end up with just x is equal to pi over 3. Now, they might change it and say, actually, you know what? We can go all the way around the unit circle. In that case, we've got two different values for x. The first one is in that quadrant 1, which is pi over 3. The second one is this quadrant right here. So I'm going to count by thirds. This is 1/3, 2/3, 3/3, 4/3. This would be 5/3. So we would have 5 pi over 3. Finally, we could take it one step further. They could ask for general solutions, which means all of the solutions. I'm not going to restrict you just between 0 and 2 pi. We know that we can continue on around that unit circle again and again. Those are called the general solutions. We would write that as pi over 3 plus 2 pi n. And we saw this before in another previous lesson. In other words, we go to pi over 3, we can go around a full 2 pi. We can go around another full 2 pi. We can also go backwards. That would be those negative values of n. We also have general solutions for 5 pi over 3. That would be 5 pi over 3 plus 2 pi n. Let's go look at another example. Let's suppose we were given the secant of theta is equal to radical 3. We're going to need to change it so it's one of those common reference triangles. Let's go change this to the secant of theta equals radical 2. Remember, the secant is related to the cosine, so that means I actually need the cosine of theta equal to 1 over radical 2. When I rationalize that, we end up with radical 2 over 2. Again, let's go back to that unit circle and think about when that is occurring. When is my x value equal to radical 2 over 2? That's right here or down here. Again, I just need to pay attention to what my restrictions are on my domain. In other words, again, if I had x is in between 0 and pi, there's only one location there. Again, that would be theta is equal to pi over 4. I switch that from x to a theta. If I was allowed to go between 0 and 2 pi, again, I've got two solutions. I have pi over 4, or this one down here. Again, if I wanted to count 1/4, 2/4, 3/4, 4/4, 5, 6, and 7. And finally, if I wanted to do those general solutions, similar to what we did above, we would have theta equals pi over 4 plus 2 pi n, or theta equals 7 pi over 4 plus 2 pi n. We're going to go and look at one more example. Alright, looking at the last example, we have cotangent of theta is equal to negative 0.6. That would mean we are looking for when is the tangent of theta equal to 1 over 0.6. Let's check out what that would be on our calculator. 1 divided by negative 0.6 ends up giving me negative 1.6 repeating, which is equal to negative 5/3. Well, that's not a common one that's on our unit circle. Remember, the common ones for tangent are 0, undefined, 1, negative 1, and radical 3. In this case, then, I'm not going to be able to go directly to my unit circle. I'm actually going to use my calculator. We're going to go ahead and type inverse tan of negative 5/3. We end up with negative 1.03, and just double checking, I'm in the radian mode in this case. So let's think about what that means. If you visualize on that unit circle, negative 1.03 radians, this is 3.14 radians, this is approximately 1.7, negative 1.03 might be down in here. Again, we're going to have to take note of what our domain is. If I was given that our answers have got to be between 0 and pi, I can't give this solution right here. So we need to think, when else is that tangent a negative? That tangent is negative over in here. How do we get from here to here? We are adding pi. I'm going to take my answer then that I had of theta equals negative 1.03, and I'm adding pi. That gives me a radian measure of 2.111. Let's go check it out. 2.11, again, 1.7 is here, 3.14 is here. So visually 2.11 is matching up. I can also mathematically check it. I'm going to go do the tangent of that answer. That's the value that I get, but remember what I started with was the cotangent of theta equals that. So now I'm going to turn around and go do 1 divided by that answer and verify I get all the way back to what I started with, and I do, negative 1.66. If I was given that my solutions could be in between 0 and 2 pi, again, I've got one of my solutions is 2.11. To get to this point over here, going in that positive direction, I can add pi to this, or I could go and add negative, or add 2 pi to this one. I'm going to go ahead and add the 2.11, and I'm going to add one more pi onto that 2.111. Adding pi gives me another solution of 5.252. If I wanted to take it one step further, and in this case they wanted general solutions, and this one throws one more piece into the mix here. Remember, your period for tangent is pi. On all of these other examples, we were doing cosine or sine, so we were dealing with the period of 2 pi. That means here I can just write my general solutions as 2.11 plus pi n. So if I start here and I add pi, I'm down here. I add single time I'm ending up here or here. So I don't have to do the 5.252 plus that pi n. It's all taken care of in this single statement. Alright, we're done with the notes. As I said, you've got a small Excel assignment. I tried to keep it on the simpler side. Most of them are going to be up in example 1 and 2 with a few down here. Just make sure you're paying attention to what your domain values are. Are you looking in between 0 and pi, 0 and 2 pi, or are you allowed to get general solutions? Again, I'll put up a discussion board if you have some serious questions.